Welcome to episode 38 of Forest Focus. I'm your host, Paul Wade, with the Regional Public Affairs and Communications Office. In this episode, we want you to listen. Well, listen to the episode, obviously. But during your outdoor adventures, do you listen? Do you hear a trickling stream? Do you hear the wind through aspens? A distant waterfall? The symphony of sounds wildlife make? It's no wonder that sound machines have these calming nature acoustics, but they can be used for study also. Have a listen.
With respect to conservation, sound is a powerful tool. Your range of detection in a forested setting by ear is far greater than what you can see. It's added to my perception of nature tremendously.
This applause for the benefits of sound comes from an expert who would know. Greg Budney, who worked for decades as a curator of audio for a library of wildlife sounds at the Cornell Lab of Ornithology. He shares this reflection at the conclusion of a course on wildlife sound recordings, which he taught at San Francisco State University's Sierra Nevada Field Campus, located within the Tahoe National Forest in California. National forests like this one are locations where we can listen to a concert of wildlife sounds. The caws, croaks, howls, growls, and squeaks we might hear are gems of information about wildlife and their habitat. The USDA Forest Service and partners work together to conserve and restore land that wildlife species need to survive. Part of that includes removing hazardous vegetation from forests so that the risks of high-severity wildfires burning wildlife habitat can be reduced. To do this necessary work and to avoid unintended negative impacts on wildlife, it is essential to know what species are in a forest, where they are located, and which aspects of their habitat are most important to their survival. But finding secretive species can be challenging, and some are easier to hear than to see. Birds provide a great example. With camouflaging feathers and the ability to fly away, soar above, or perch on high, it is often difficult to get a good look at them. This is especially true for nocturnal birds like the California spotted owl, which are most active during dusk and in darkness. For years, researchers have relied heavily on having surveyors out in the field listening for bird calls in real time to locate different species. But this requires having highly skilled people in the woods for many hours and for long periods of time. With sound recordings, including those collected by devices left out in the forest as passive listening ears, we can listen in more locations, which helps amplify efforts to conserve these species. Welcome to episode 6 of Echoes from the Understory. This series is all about forest health, what it means, why it matters, and how it is secured. Audio gives us boots on the ground connections with our public lands, where we can immerse ourselves in the soundtrack of forest health. One indicator of forest health is biodiversity, which is the variety of organisms you can find in a forest. Each organism fulfills a role within the forest to keep it functioning. The level of biodiversity that is required for a forest to be healthy and functioning varies by forest type. Researchers and land managers monitor how work done in the forest affects native species so that the negative impacts can be minimized. Recording wildlife sounds to regularly identify species within a forest helps them do this. In this episode, we will focus specifically on bird biodiversity. We'll explore how audio recordings of bird sounds helps us know what kinds of birds are in the forest and where they are. First, we will lend an ear to Greg Budney within the Tahoe National Forest. He will tell us how human recordists collect bird calls, chirps, and whistles while they are out in the field, microphone in hand. From this visit, we will discover how national forests are classrooms for the art and science of wildlife sound recordings and the applications these recordings have for conservation. Then we will head to the Sierra National Forest where Aaron Natowski, a bioacoustic researcher with the Peary Lab at the University of Wisconsin, will tell us about autonomous recording units. She will explain how these devices are pre-programmed to record during set hours of the day, hiked out into the forest, strapped to trees, and left to collect bird sounds as part of passive acoustic monitoring of California spotted owls. Let's meet our first acoustic expert.
I'm Greg Budney. For just over 35 years, I was the curator of audio at the Macaulay Library, which is a library of wildlife sounds at Cornell's Lab of Ornithology. I'm now retired and still pursuing recording and training people as I can.
Training others is why we find Greg on the Tahoe National Forest today.
We're here at the Sierra Nevada field campus of San Francisco State University. And this is a facility that's been located here in the Tahoe National Forest on Forest Service land since the 1940s. It was started by biology professors, one of whom went on to start the Charles Darwin Station in the Galapagos. So it has a great history. This particular location offers us a tremendous variety of habitats because of the elevational gradient. We can go from about 5,000 feet to 7,000 feet in a matter of half an hour, from chaparral habitat to closed forest or even above tree line. It's really a superb place for undertaking this type of field recording. So our field course here is titled Wildlife Sound Recording. And we take people who have an interest in nature and wildlife into the field on a daily basis, and we spend about 4 hours field recording. The participants come from a range of backgrounds from around the globe. We've had people from Uganda, Switzerland, Chile, Britain, Canada, New Zealanders, Israelis, and Palestinians right here in the Tahoe.
Learning how to record wildlife sounds can help us make deeper connections with national forests and the natural world. This is part of what draws Greg to continue to record wildlife sounds himself and to train others to do the same.
One of the things that is particularly enjoyable about teaching this workshop is when someone puts on a pair of headphones and uses a directional mic for the first time. Countless times you see someone's mouth open up and they'll say, wow, they've never heard sound that way before. When you listen through a microphone, your mind doesn't filter things out in the way we normally do. As we go about our daily lives, we filter things out in the soundscape all the time. We don't pay attention. But when you pick up a microphone, put on a pair of headphones, it's an opening of the oral sense in a way that most people haven't ever experienced, and it catalyzes an appreciation for the natural sounds. It's an endless process of learning, and you always hear new sounds. And there's just a tremendous feeling of being able to walk through a habitat and say, oh, that's a McGillivrays warbler over there, or that's a yellow warbler singing over there.
Along with enhancing our relationships with forests and the creatures that share these spaces with us, wildlife sound recordings have additional benefits.
There are a number of uses. One is to document what the biodiversity is in a particular area. And in a forested setting, you can hear much further than you can see. If you have to rely strictly upon visual ID, it's going to take you a lot longer to determine what's in a given area. There are now autonomous recorders that can record either a program period, say 3 or 4 hours around dawn and dusk, or they'll run 24/7. In fact, there's a project going on to monitor spotted owl, and there are many, many autonomous recorders that are being deployed in the forest.
That's our cue to head south to the Sierra National Forest for a meet and greet with some autonomous recorders and our next acoustic expert.
My name is Erin Natosky. I'm a bioacoustics researcher with the Peary Lab at the University of Wisconsin-Madison. I'm one of the crew leads for our long-term monitoring project that uses acoustic surveys to detect California spotted owls across the entire Sierra Nevada mountain range on national forests. We work all the way from up north in Lassen National Forest down through Sequoia National Forest. And this project has been going on since 2017, and this is our third year of doing full monitoring for the entire Sierra Nevadas.
The California spotted owl, the bird that is the subject of this long-term monitoring study, is a subspecies of spotted owl. It can be found in the Sierra Nevada mountains of California and Nevada, in portions of southern and coastal California, and in a portion of Baja California. It is similar to, but distinct from, two other subspecies of spotted owl. The northern spotted owl, which can be found in northern California up into British Columbia, and the Mexican spotted owl, which can be found in Utah and Colorado down into southern Mexico. But we are here to learn about the California spotted owl, and Erin tells us about their appearance and vocalizations.
They're maybe a foot tall or so, and as their name suggests, they are very spotted. They have a light tannish cream breast with brown spots and a darker brown back with lighter spots on it. Very cute, round faces and beaks. They have a couple of distinct vocalizations that they do: the four-note, the bark, and the contact call. The four-note is the most common. Both males and females will do this. Males are a little bit lower in pitch and females are just a little bit higher. So actually when you listen to a recording or look at it on a spectrogram, you can tell the difference between males and females. They also do a bark and then a contact call, which is a really high-pitched whistle. When the female is on the nest, just say, and the male is coming in, they'll contact call. And then juveniles also have their own distinct, very high-pitched, raspy kind of vocalization that they do.
With this visual and vocal portrait of the owl in mind, let's dive into why and how the Forest Service and partners like the University of Wisconsin are monitoring these birds. One important reason is that populations of California spotted owls have been in decline due to a variety of past and present factors. First, many forests in California are overgrown due to a century of overemphasis on fire suppression. These crowded conditions allow wildfires to grow large and burn owl habitat at very high temperatures. Drought, insect outbreaks, and tree diseases are killing forest trees, which increases the risk of future large hot fires. The owl has been impacted by other factors too, including past logging practices that overharvested big trees, and also the rising populations of the non-native barred owl, which competes with California spotted owls for food and habitat. Due to the combination of these factors, the U.S. Fish and Wildlife Service proposed to list the California spotted owl as a threatened species in the Sierra Nevada in February 2023. Although the proposed listing is relatively new, researchers and land managers have been striving to better understand the habitat needs of California spotted owls for decades so they can reduce wildfire risks and conserve owl habitat. Previously, monitoring protocols required having surveyors call and listen for birds in real time when they are out in the forest. This practice is still used and has benefits, but it requires having skilled experts in the woods for many hours and many days. But there is a lot of land to cover in national forests in the Sierra Nevada mountains. What has changed in more recent years is the use of technology to survey more area in less time.
We have around 1,800 autonomous recording units, or ARUs for short, throughout the entire Sierra Nevada. With traditional survey methods, you have to be physically on the ground, but acoustic recorders are programmed to record during specific hours of the day and can pick up sounds anywhere from 200 meters to 1,000 meters. We can leave them out for much longer and get a more accurate representation of owl populations in an area, because sometimes within a week, you might just have one owl passing through on a night of hunting and he's not actually a resident of that area. But if you pick up that owl consistently week to week, then you can say with more certainty that the owl is a resident.
Knowing where owls are nesting and where they are just passing through is an important distinction for land managers. This information allows them to conserve essential habitat features for owls in the places that matter most, which is the nest trees and the immediate surrounding area, while reducing flammable vegetation in areas farther from the nests where owls hunt for food and tolerate a wider range of habitat conditions. Erin shows us how these recorders are set up to acquire this useful data.
Place the recorder on the tree at about chest height with the microphone facing down, and then throw the strap around the tree. And then once you have it attached to the tree, double check that standby blue light is blinking, and if it is, you can walk away.
As another wildlife biologist has explained it, this passive listening to catch a sound of an owl can be likened to waiting to catch a fish. The recorder is like a fishing line, left out in the water for a prolonged period, and the unique call of the owl is like the fish we hope to capture. After the recorder has been left out fishing in the acoustic atmosphere of the forest for around 5 weeks, it is time for the retrieval quest.
We're in Sierra National Forest, just south of Yosemite National Park. We are currently in our retrieval stage, so we are going throughout the forest where we deployed acoustic recorders throughout April through June, and we're picking them up to collect our data. Just take off the strap. So that's it for the collection.
Next is where sound mixes with sight with a dash of computer learning.
So when the technicians bring the collected recorders back, we take the SD card out, then we plug it into the computer. Once we have everything on the server, that's when we send them to Cornell.
This is the Cornell Lab of Ornithology, the same organization that Greg Budney worked with for decades.
And that's when BirdNet will start pulling the files. BirdNet is a program that was developed by the Cornell Lab of Ornithology, and it's able to identify the look and structure of bird calls on a spectrogram. And a spectrogram is basically the visual representation of what's on a recording. Wildlife calls are usually pretty distinct in how they look. Even sometimes without listening, you can identify the spotted owl based on the shape of it, which is the frequency, the amplitude. BirdNet gives us this output for each recording of where it thinks it's identified the spotted owls. Although it does a great job, we do still go in afterwards and manually vet the BirdNet data and basically confirm whether or not it was correct.
The collection and uses of sound recordings is an evolving blend of boots on the ground, automation, computer learning, and human minds analyzing the data. We'll keep tuning in to the reverberations this will have for long-term conservation. Today, our acoustic experts have revealed that while there is much to see in our national forests, there is also much to hear. Sound recordings of wildlife help us learn what kinds of species are out in the woods, and this invites us to make use of our other senses so we can deepen our connections with national forests. Sound recordings also help us know where specific species are living in forests. This helps us know what areas may need to be prioritized as habitat for species with populations in decline, like the California spotted owl. In parting from this forest visit, Erin leaves us with some of her reflections on the world of bioacoustics.
It's a great opportunity to do a really large landscape wildlife survey to look at the landscape, or defined in this case as the soundscape, as a whole. You're contributing to data and science that is going towards active conservation for a species, which is pretty wild, I think, and exciting.
This episode was produced by me, Jamie Henricks. Theme music is from Pixabay. Keep your eyes and ears out for the next episode of Echoes from the Understory.
Well, I think that when you put on headphones and listen to this show, you always say, wow. But maybe that's just me. Oh, and bird watchers. So next visit to your favorite outdoor place, try and listen more to your soundscape than looking at the landscape. Thanks, Jamie, and to all of our heightened hearing guests. Oh, sorry, hope our levels didn't just peak there. To learn more about these researchers and their projects, go over to the show's description page and click on all the links. Thanks for listening, and if you're interested in sharing or listening to more episodes, search Forest Focus Podcast or look for us wherever you get your podcasts. And if you have questions or suggestions for a show, email us at sm.fs.r5ffpodcast@usda.gov. Until next time, enjoy your public lands. Please remember to recreate responsibly, know before you go, and learn what you can do to prevent wildfires. Take care. This podcast is sponsored by the U.S. Department of Agriculture, Forest Service, and the USDA is an equal opportunity provider, employer, and lender.